We are working on an imprint project on water and agriculture. The focus of this project is using smart sensors combining with satellite products for giving irrigation scheduling, irrigation management in these agriculture farms. So we are here in a village in Chamarajnagar district called Berambadi village, and in Hangla Hobli. What you see is a sensor which we are collaborating with Bosch team, who are the group of Bosch AgriSense group. This sensor is measuring ambient temperature, humidity, soil temperature, soil moisture in the station here. And along with this, there are sensors in different farms. You can see a finger millet farm here. You have a banana farm here. You are going to have a marigold farm here, and so on. So these farms, each one, because the cropping practices vary from one crop to another plot, their moisture needs are also different from crops. So the idea is that we can't have large number of sensors in every farm, one sensor. So hence the idea was to combine some ground-based sensors with satellite products to be able to provide information to each farmer plot of soil moisture. So the goal is that when we want to do that, we combine different products of satellites. For example, there are satellites which coming from on a daily or a two-daily basis. We have soil moisture at a larger scale. Once in 10 days, we have soil moisture coming from SAR data sets from a different set of satellites. So we combine them to generate disaggregated products on a daily scale. And since they are based on satellite remote sensing for farm plots of small areas like 1 hectare, half a hectare, there is relatively sometimes bias in the satellite products of soil moisture. So to improve that, the idea is to have a cluster of sensors in different parts of a district in such a way that we debias the soil moisture data coming from these disaggregated products of satellite, and then provide them through an app to each farmer. For example, here is an app in this farm where you can see the soil moisture, you have the soil temperature, the ambient air temperature, ambient humidity are all seen. This is provided as an information to the farmer where there is a sensor. We also provide the information to a farmer where there is no sensor. That's because we are able to evaluate this soil moisture data in a farm outside where the sensor is, and that also is given as an app to the farmer. And the idea is that once the soil moisture is available, the farmer will have a good decision to apply water judiciously. The irrigation systems, for example, you see here a pipe water from groundwater irrigating. So they are putting drip irrigation. So you can see there the banana farm is drip irrigation. So the farmers are trying to already use a lot of technologies to improve the water use efficiency and use less water footprint. But then they also need to know how soon they irrigate, or how infrequently or frequently they should irrigate when there is already a rainfall and so on. So the moisture states will help them, give them an idea when to irrigate, whether the moisture adequacy is enough in a farmland. So that's the idea of the goal of this project, where we would like to provide the farmer with a lookup information to make a decisions on his irrigation to save precious groundwater. In most of these places, people are irrigating, blending groundwater with rainfall during Kharif season. During non-rainy season, they use the precious groundwater for continuing the crop. So the idea is that by improving the water use efficiency by providing information to the farmers on the moisture states, we could reduce the water use in the farms and improve the water efficiency. That's the idea of this project. Thank you.